Rules for differentiation or differentiation formulas enable us to find the derivatives even in complicated functions.
Let's get ready to rumble!
The first rule or formula is the derivative of constant c with respect to x is 0. Any constant number has a derivative of 0. We discussed this in previous videos.
Are you sure about that?
The second is the identity rule, which states that the derivative of x with respect to x is 1. We also discussed this in previous videos.
Are you sure about that?
The next is the constant multiple rule, which states that the derivative of constant c times u is equal to c times the derivative of u, or dy over dx is equal to c times du over dx, in which u is any differentiable function of x and c is a constant. You may be wondering, how is this formula derived? Let's derive this one.
Floor. Great give and go.
Now, let y equals cu. Then any change in y corresponds to a change in u, or y plus delta y equals c times quantity u plus delta u. Transpose y to the right, so delta y equals c times quantity u plus delta u minus y. But y equals cu, so substitute cu to y. So delta y equals c times quantity u plus delta u minus cu. Going back to dy over dx is equal to the limit of the change in y over the change in x, or delta y over delta x, as delta x approaches 0. Let's substitute the value of delta y we derived. So c times quantity u plus delta u minus cu over delta x. Then use distributive property of multiplication, distribute c. So cu plus c delta u minus cu over delta x. Cu cancel as 0 due to opposite signs, so the limit of c times delta u over delta x as delta x approaches 0. And this limit of delta x, as it's approaching 0, is the derivative of u with respect to x, so dy over dx is equal to c times du over dx. Example: y equals for x to the fifth. The constant here is 4 and u here is x to the fifth. Using the power rule, the derivative of u with respect to x, or du over dx, is 5x to the fourth. So using the rule or the formula, we have dy over dx is equal to c du over dx. Substitute 4 to c and 5x to the fourth to du over dx, so we have dy over dx is equal to 4 times 5x to the fourth. 4 times 5 is 20, so dy over dx is equal to 20x to the fourth. This is the final answer. In deriving the formula, I use delta notation to illustrate that we solve for the rate of change, but you can use h here as illustrated by others. You can also use y prime for dy over dx.